Welcome to this P1 revision session on infrared radiation and thermograms. By the end of this session, you should be able to do the following three things. Firstly, recall that all bodies emit and absorb infrared radiation. Secondly, describe how to investigate what surfaces are good and bad at absorbing infrared radiation. And thirdly, describe what a thermogram is. There are four key words that you're going to need to know the meaning of for this unit. They are infrared radiation, emit, medium, which is required for higher tier, and thermogram. Pause this slide now and see if you can write a definition for each of these four words. Right, now you've had a chance to write a definition for these words, let's go on and have a look what the actual definitions are. So, infrared radiation is the transfer of energy by electromagnetic waves. Emit means to give out, in this case energy, but to give out anything. A medium is any substance. So to put that into context, a vacuum is a place with no medium, so such as space. And a thermogram is a picture taken with a camera that is sensitive to infrared radiation instead of visible light. Just in case you could hear that noise in the background, I am recording this at school and someone just did a call out on the radio. So we're going to start off by looking at emitting and absorbing infrared radiation. So first of all, we need to be clear in our mind what infrared radiation is. It's a type of electromagnetic wave, and that's found on the electromagnetic spectrum. You will see this again in a later revision session, but just to give you an idea, if you look at the wavelength, which is this section along here, infrared radiation falls in here. And so the wavelength of infrared radiation is longer than that of the wavelength of visible light, and it's even longer than the wavelength of ultraviolet light. So what this means is that waves with a longer wavelength have got less energy. So infrared radiation has got less energy than visible light and less energy than ultraviolet. On the next photo, I'm going to want you to tell me what two types of energy are being given out. So this is an electric hob cooker ring, and there are two types of energy in particular being given out that I want you to tell me. So pause this slide if you need to and think about that. Now you've had a chance to think, let's have a look at these two types of energy. Okay, there's infrared radiation, which is being given out as heat, and there's also red light. So that's obviously why the ring looks red. And if you remember, both of these are next to each other on the electromagnetic spectrum. Infrared has got a longer wavelength and less energy than red light, but they've both got a very similar wavelength. Now this actually does have very useful practical implications. So let's have a look at the next slide and we'll talk about those. Right then, so you've got images of 3 England cricket shirts there. I know they're from different eras for those of you who like cricket, but that's not the point of the slide. The point is looking at the colour difference. So the question is, which of these shirts would absorb the most infrared radiation and why? So pause this slide and have a think. Well, you probably know that white is the most traditional colour for cricket shirts, and if you think cricket is an all-day game played in the summer, so you're out all day, hopefully in the sun, but we are in England, so probably out in the rain, and so the players out there would want to keep as cool as possible. These shirts here, the blue one and the dark blue training shirt, are becoming more common, but this is mainly in the shorter form of the game. Well, if you're only playing for a shorter amount of time, you're not going to be so worried about getting hot because you're going to be coming off the pitch very soon. And for a training session, you might only be out there for an hour or so. So this means that the white shirt should keep the player cooler. Okay, so overall this is what you need to know. The surface of an object affects how much energy it absorbs. And there's two main things that affect this. Firstly, the colour, and also whether the surface is matte or shiny, so dull or shiny. So if you've got a surface that is a dark colour, which is made of a matte material, so it's not shiny, then that is going to be good at absorbing infrared radiation. On the other side of that, if you've got a shirt or a surface that is light coloured or shiny, so something like aluminium foil for cooking, that's bad for absorbing infrared radiation. If you go down to the kitchen at home and have a look at aluminium foil in the kitchen, you'll see that one side is very shiny and the other side is dull. It's got a matte surface. So if you want to absorb energy, you're going to want to have that matte surface on the outside. It's a common mistake. People normally put the shiny side on the outside of the chicken or whatever they're cooking. But if you think a shiny side is bad at absorbing infrared radiation, the heat energy is coming from the oven outside of the foil. So actually you want to absorb more of the energy, so you want it the other way round. If you have it the other way round, with the matte side on the outside, this is going to be better at absorbing the radiation. And once the heat energy is inside and it's reflecting round inside, then that's going to bounce back round inside that foil casing, because the shiny side on the inside is bad at absorbing infrared. And when it comes to emitting or giving out infrared radiation, then the same thing applies. If you've got a surface that is a good absorber of infrared radiation, so a dark surface or a matte surface, that's also going to be a good emitter of infrared radiation. And the opposite of that, if you've got a light coloured surface or a shiny surface, which we've already said is bad at absorbing, it's also going to be bad at emitting infrared radiation. And now we're going to move on to the next bit, which is thermograms. Okay, and as it says there, a thermogram is not a unit for measuring the mass of hot objects. It's got nothing to do with grams and kilograms. So we might as well look at a thermogram to start with. So here is a picture of a house taken as a thermogram. Think back to those key words. A thermogram is a picture that's taken where instead of having light, you're actually seeing infrared radiation, heat energy, being represented as light. With this, it's very easy to spot on a house like this areas where you're losing a lot of energy. So the windows here are much brighter and lighter, so even though this has probably got double glazing, you're losing a lot of thermal radiation from it. And if you look at the top of the chimney there, that's also very hot, but there's probably not a lot you can do about that, because that's where your waste gases from your fire are coming from. Up here on the roof does appear to be quite well insulated, and it looks like there's tiles that are overhanging here, and that appears to be well insulated as well. But these walls are very bright, both here and here. So if I was this homeowner, I would be thinking that these walls are going to cost me a lot of money because I'm losing a lot of energy from them. And in a later revision session, we're actually going to look at how to insulate the house and the cost of doing that. And if you think back to last winter, when we had loads of snow, if you looked around the houses in your area, you might have seen something like this. You've got two houses here which are basically identical in design, yet one of them has still got snow on the roof where the other one doesn't. So clearly one of them is giving off from inside the house a lot more radiation, because it's causing the snow to melt. So this house on the right here, I don't think they'll have any insulation in that loft, or if they have, it's very little and it's highly ineffective, because lots of infrared radiation is getting out, it's melting the snow, and that's why you can see the normal roof. Whereas this house on the left, you've still got a decent covering of snow, which clearly means the insulation they've got in the loft is doing its job, and it's going to keep that heat energy in by trapping it inside. And now we're going to get to everyone's favourite part of these revision sessions, that's the exam question. So this question was taken from a recent core science exam paper, and it says Nihal takes a black and white thermogram picture of his house, and that's labelled up there. Explain for 2 marks what the thermogram shows and why it's useful. So what I want you to do is I want you to pause this slide and think how you will be able to get 2 marks for this question. Now you've had a chance to think, let's have a look where these 2 marks come from. Right, the first mark is for explaining what the thermogram shows. You see, and the thermogram shows heat as light colours and cold as dark colours. So you can see that these windows here are much lighter, so that's where the heat is. The second mark is to explain why a thermogram is useful. So this thermogram is useful because Nihal can see where the energy is being lost from his house. And as I said, in a future revision session we will be talking about insulating houses. Okay, so now let's go through what we should have learnt in this revision session. Okay, so you should now be able to recall that all bodies both emit and absorb infrared radiation, and maybe you should be able to describe how to investigate what surfaces are good and bad at absorbing this infrared radiation. If I was going to do this, I'd perhaps look at some beakers or test tubes full of boiling water and covering them with different materials. So dark materials, foil, light materials, and measuring the temperature. So clearly, those ones that are good at absorbing infrared radiation will also be those ones that are good at emitting infrared radiation. So by taking the temperature inside over time, the ones that are emitting the most, the temperature is going to go down the greatest amount. And finally, you should be able to describe what a thermogram is. It's one of these pictures where infrared radiation is used instead of light, and it's very useful because we can use it to identify areas of heat loss. So still to come in this series, I know I've mentioned it a couple of times already. The next revision session is going to be about insulating your house and the payback time, and the next one after that is going to be about useful energy and energy efficiency. Well, I hope you've enjoyed this session, and you'll be tuning in to the next one when it goes onto YouTube.